So in this video, we are going to go over the problems that we didn't do in class about reaction mechanisms. We're going to do 51, 52, and 53. So if there's a specific problem you want to go to, just skip to there in the video. But I'm going to go in order. So let's do 51. Consider the two-step mechanism for the reaction. One slow, so that's number one. Number two is fast. What's the overall reaction? So again, all we have to do is add the molecules on the same side of the arrow. So NO2 plus Cl2, and those are our first two. Then NO2 plus Cl, and that will make CiNO2 plus Cl plus C, that's ClNO2, not Ci. All right, and then I'm going to simplify. So what I'm going to do is I'm going to look for any intermediates. And so that would be Cl. So that's actually the answer to B. Cl is our intermediate. Now I'm going to combine like terms together to make this look nicer. So we have two molecules of NO2 plus Cl2 makes ClNO2, and we have two molecules of those. That's the answer to A and B. Now we have to do C, which is what is our predicted rate law. And so we go to our slowest step and we say rate is equal to, well, this is our first reaction, so we'll do K1. And then we look at our reactants, NO2, Cl2. And we ask, do we have any intermediates here? We don't. So we're actually done. That is the answer to C. Now let's go on to 52. 52, more of the same. Here I give you the overall reaction though, so we don't have to do that. So here's our mechanism. We have a slow and fast mechanism. So given the mechanism, what is the rate? So going from my slow mechanism, rate equals, well, this is my first reaction. There's my second. Rate equals K1, NO2, Cl2. Again, I'm just reading off my slow mechanism to get this. And then I asked, do I have any intermediates? I don't. NO2 and Cl2 are reactants in my reaction, so I'm done. That's it. Let's go on to 53. 53. Here, again, I give you an overall reaction. Then I give you two steps, one fast, one slow. And again, I want the overall mechanism. So we start with our slow reaction and we write down the rate law. Rate equals K2. Since we have two A's, that becomes A squared. Since we have two B's, that becomes B squared. Remember, any stoichiometry coefficient becomes a square. Now we look at our overall reaction. We ask, do we have any intermediates? And we do. A is an intermediate, right? In our overall reaction, we have A2, but we don't have A. So this doesn't appear in our overall reaction. So we can't have it in our rate law. So I need to substitute this out. To do that, I'm going to go and use my chemical knowledge. And remember, any fast reaction above a slow reaction reaches equilibrium. And at equilibrium, my forward rate is equal to my reverse rate. So I'm going to write my forward rate first. So that's just reading from left to right. That is rate equals K1 A2. Now I'm going to write my reverse rate, which is rate equals K minus 1. So I'm using the minus 1 to say reaction 1 but reverse. And then we have two A's as our reactant because I'm reading right to left. That's A squared. Very bad A, but that is A squared. And remember, the reason why we're doing this is I need to substitute A squared out of my rate law. And I can do this because since these rates are the same, I can set them equal. K1, A2, is equal to k minus 1 a squared. I need to solve for a squared, so divide each side by k minus 1. And I get a squared is equal to k1 a2 divided by k minus 1. All right, now I can plug that in to my rate law. And I'm going to do that. So my new overall rate law is rate equals k2. Then we have a squared here, so I need to substitute that out. K2 times k1 times a2 divided by k minus 1. I actually drew my division sign a little long there, so redo that. K2, K1, all over K minus 1. And then that's the a squared term, right? That's what we got from here. And so then we have b squared for my original rate law. And then we ask, do I have any intermediates? Well, we have A2, that's a reactant, so that's fine. We have b squared, we have b rather, you can ignore the square, we have b, and we see in our overall reaction, we have b. So we're fine, so we're good to go. What I'm gonna do though, is I'm gonna make this a little cleaner. Whenever you have multiple k's, you can simply say all of these k's are just equal to k, right? K2 times K1 divided by K minus 1, well, that's just K. So be KA2 B squared. And that is the rate law. And that's how easy mechanisms can be. If you have any questions, let me know. Otherwise, I will see you in the next video.